talk about LINQ. In order to get there, we need to see, just dig a little bit more into some of the details. We talked about some of these features last time, but we'll dig more into them and then try to do small examples on them, just to see how it's working. So the idea is, hopefully we have the time for doing that, that each of these language features, at least some of them, not necessarily all of them. Then what I will do is I will introduce to them, and I will try to make a small example to see how to actually how to do that. So I'll do some live programming from here, so you can see how some of the examples. So you can follow along, and it's not necessary that you follow along. If you can't follow along, it's fine. No big deal. I will upload my workspace to Moodle after, so you can go home and think, I need to see that again, and then you can see how I did it. I didn't try, but you need to try. It's like, I don't know if we talked about it last time. Programming is like there's not that huge difference of learning to program and learning to play guitar or piano or something like that. There's no way that you can sit down and read all you need in a book. Yeah, you can probably read a lot about playing the piano, but I don't think anybody wants to listen to what you actually want to play if you try to do that. And it's pretty much the same with the programming. You can read a lot about programming, but nobody can use whatever you're capable of doing if you haven't tried. So hands-on, do it. That's the only way forward. And if you want to be good, program every single day for the rest of your life. That's just set aside an hour or two in average to be programming every single day, because it's the same problem as with playing the piano. If you stop playing the piano, you lose your skills. Of course, it's easier to get them again, but you lose them. So yes, let's start to talk about one of the features. First feature is lambda expression. So we talk about lambda expression. We talk about extensions method, anonymous types. We will talk about the query expressions from LINQ. We will talk a little bit about generics. I will talk about iteration. That's the yield and stuff here. So try to see if you can make small examples. So because sometimes it's easier to understand if you also see, instead of just seeing it on the slide, also see some live examples. So we talked a little bit about lambda last time. Talked a little bit about this was anonymous function that you have. So if you look at another way to think about lambda, or it's also, the concept is also called delegates in C#. So a delegate is this idea of having a function as a type. So as part of the system, you can not only have integers and doubles and persons and whatever, houses, objects, but you can also have a function as an object, as a type. So not as an object. So we can declare a function. So that's what we're doing here. So the function have some access modifier, also have a name, take some parameters as argument. So that's the definition of the function. You know that, you have seen that, you have done that, you have made a ton of methods, so you know you have, that's the signature of a method or a function. So a method is just a specific function that is inside a class, so that's why it's called a method. But the more general concept is a function, because that's also the mathematical concept. So a function is so sometimes I will remember to say methods when we are talking about classes, but in the end it's all about functions. So it has a signature, and then what we can do if we have a type, a declaration, we can have instances of that type. So these two are actually instances of this type. They follow that signature. So you can see the signature as a type definition. Like whenever you say, here's an integer, but you don't say anything about the variable or the value, you just say this is something that can hold an integer. So that's a piece of, it's a reference or a piece of memory that can hold an integer. Or this is a class. The class this is a class person, it have a name and age. So that's the type definition of the person. And you can instantiate these so you can create ones with specific values. So you can do that. You can think in the same thing terms on functions. So this is an instantiation of that function, and this is an instantiation of that function. So you have the same return type. Take the same argument. That's the only thing we need to know when we are talking about the functions as types and instantiation. What is the return type and what is the parameters? The name here is like naming something in integer or double. It doesn't matter. It's just the name of the type. So that's just, so f here is just the name of a type that returns b and take a as an argument. And anything that does that can be an instance of that. Do you follow me so long? So if you have done anything functional programming, you know that this is how you think about it. If you haven't, it's probably weird that you can have function as a type, but that's the idea. It also means that we're capable of passing functions around in the system. So like you can call a function and give it an integer as an argument. You can call a function and give it a function as an argument. That's weird. That you can pass a function to another function. So you can say, okay, here's a function, execute that function sometime in the future when you are being executed. So that's the main idea. So being able to pass function as arguments is the primary goal, because then we get a lot of flexibility, a lot of possibilities. But it switched the paradigm. So we're switching from the paradigm of object-oriented programming into something more in the functional programming world. And C# will become something in between these two. Of course, it's an object-oriented language, first of all, but it has these functional programming features. So is it useful? Yeah, it is. Otherwise, it wouldn't be there. So first of all, it's useful because it makes the code easier to read. So if you have some of the problems that we have to solve is that if you have this sort function, so you have a function that can sort something, that's fine. But what is the criteria for sorting it? So you're not giving that as a part of the. If you don't give that as a part of an argument, then it has to be something that is defined inside the function. So the function knows how to sort an array. And one simple solution is just to use standard operations to sort it. So you can just use less than or greater than or whatever equal to operation. That works fine as long as we have value types. But when we move into object to reference types, so when you have an array of persons, how should it sort it? So sorting it doesn't make sense because it does can sort it by the address in memory. Doesn't make sense. So it doesn't know how to compare two persons. So somehow we need to hand in some definition of how to sort the person. So do you want to sort them by age or by first name or by address or whatever? So somehow we need to add some more information. Otherwise, the sort algorithm doesn't give you anything, because then you have to write it yourself. You have to do all the hard work yourself. So we want something like this. We want to be able to give an array of something, collection into sort, and then something that defines how we want to sort it. Of course, with integers it's pretty simple, but anyway, do you want to sort it ascending or descending? Or what? That could be. So if you don't have this possibility, you have only one choice. So then we can have a type definition of of a compare delegate. So that's something that returns an integer and take as an input two integers. That could be the type definition of a compare function that we can pass into the sort algorithm or sort function. So and then we can make two different instances of this compare function. What you can see, they have these two functions here have the same signature. Of course, it doesn't have the same name, but it returns an integer and take two integers as an argument. That's all we need. So everything that does that is fine. You can pass any function that does that. Of course, it can do nonsense. It can do whatever. It doesn't care about that. The only thing we care about is, does it follow the signature? Return an integer, take two integers as an input. Then it's fine. Just pass it in, and then the sort function will just use it to say whenever I give it two integers, I expect it to compare them. So if the first one is less than the second one, it will return something that's less than 0. If they're equal, it will return 0. And if it's greater than, then it returns a positive number. That could be, that's the definition inside the sort for the compare function. If it doesn't do that, then you don't know what you get. Probably not something that is sorted, but the sort function don't care. It's the only thing it cares about. Give me something that returns an integer and take two integers as an input. So in this case, they both do, and they happen to do something that's useful. So if we have this array, that's the array over here, and we call that sort function with the ascending order, we will get this one, and descending we get the other one. That means now we can actually, it's like adding a parameter to the sort function, so the sort function becomes more useful. Can you follow that? Now you not only have one way to sort something, you have all possible ways to sort something. In this case, we take two integers, and that's of course a very simple solution. So we can introduce generics, and then we can solve the problem, and we can have generic sort functions that can sort any type. So take two of any type, and then can be able to compare them and return an integer. -1 if they are less, the first is less than the second one, 0 if they are equal, or 1 if the first one is greater than the last one. So that's the idea. That's why it's very useful. I mean, it's used heavily in LINQ. So you use delegates all the time. So how do we define that in C#? So this is a delegate. So that's how you define a delegate. You can define name delegates, so you give it a name, or you can define anonymous delegates. This is the last one. So we define that we want to assign a function to this variable here. That function that's an instance of a type. A type that is a delegate here. So we have a delegate we take as its input an article, and it returns the title of that article. It's not a very useful depends on what you're doing, but that's an example of a delegate. How do you define that? So it follows this structure of this one up here. So it takes as an input an article and return a string. So that's the type, and as long as we follow the type, everything is fine. So lambda expression is something that's very often used and has been used a lot in math. So the representation of a lambda expression is that you can map something into something else. So this is an example. So this is the delegate. So the first version of delegates in C#, I think it was in version 2 of C#, something like that. There was no delegate, no lambda. There was only these delegates, so that you have to write this every time you need to create an anonymous instantiation of a function type, you have to write all this. And most of this is just the boiler code. Delegators, so they came up with this idea, inspired of a lot of other languages that already had that instead of writing all this code, you just write this code here. So this code and this code is exactly the same from the compiler point of view. It knows exactly. So you say, okay, what did we take away? First of all, we don't have to write delegate here. That's the first thing. Okay. Do we actually need to define the types here? No. The compiler can actually infer the types. It knows the type because eventually you call this one and then it knows what the type is. Or what about the return statement? Do we need to define that whatever we return, the type of the return? That we can infer that too, because if we can infer these three guys, we can also infer that what the type will be. If they are all integers, this must be an integer. If it's not all integers, then there's some rules how plus is working. Whenever you have, if you plus an integer with a double, what is the result then? Just follow that so that the return will be that type. What about the return statement? If somebody expects this one, that this actually can be assigned to something, then it needs to return something. And then what it will return is just execution of that part there. So that's the lambda expression. Makes it very compact, very easy, not overloaded with a lot of stuff that doesn't carry any information. Very compact and very weird when you see it the first time, because what the heck is going on here? So if you haven't seen lambda expressions, you have to get your head around it, because it's a little bit tricky in the beginning.
Just a question.
Yeah, absolutely.
Like in a normal .NET versions or frameworks, I think so they're not using much in lambda expressions, but in MVC nowadays they are more useful for lambda expressions.
But all the link is using lambda expressions all over the place.
Okay.
So it's used heavily also inside the. So it's not only in ASP.NET MVC. It's used a lot, because it's a very useful. Working with collection is very useful. You will see that. You will see what the power of link is later today, and you cannot do that without lambda. Without lambda, link would not be there. You need lambda to do link. So the problem is, whenever you want to, if you want to define a function that take as an argument a function, how do you do that? So then you have to first define a delegate, that's the type, but then you can use that type as a type inside the function. So because otherwise, how do you define what should be the signature? You want this function should take a string and then it should take another function. So how do the compiler know what this function is? I need to create a delegate, give it a name, and tell what should be the return type and the arguments for that delegate. And then I can use the name of that delegate as a type in this function here. So I make a type x, and then I can say that this function should take as an argument a string and an x, and x is then a function. So I have to define these delegates whenever I need to create a function. But the only thing I'm interested in these functions, the definition of these delegates, are the output and the input. The name doesn't matter actually. The name is just for defining the type, and the type is what does the delegate return, and what are the arguments, all the parameters that they need to pass in. So instead of you need to write all this all the time, they have a number of generic delegate types. So One of them is an action, and an action is a void function. So that's a function that returns nothing. So that's a function that just executes something, but doesn't return anything. So if you create this one here, so say the argument should be action, and then you have a string there. Then you say this is just a void function that takes one string as an argument, like this one here. So it's a void function that takes one argument, and that's a string. That would be, if you want two arguments, you should take a string and an integer. You just say string comma integer. So you can just extend that list, and that list will just be exactly the list of types that your function need to have. So that's one. That's if you have void, then you use this action. Predicate is something that always returns a Boolean value, so it returns true or false, and it takes arguments again. So whatever argument you give to predicate will create this delegate here. So in this case, it will create a delegate that actually doesn't have a name, so you don't need to have it. But it returns a Boolean and it takes two strings as an argument. So when you read something, so a predicate, that's the definition of a predicate if you run into that concept. A predicate is something that returns true or false and takes some arguments. And finally, that's the general one, a function, func. And what it does is actually it defines that the last argument here is the return type. So the last argument is a return type. That means that you can write whatever you like. If you only have one argument, you are creating a function that doesn't take any arguments but return whatever you want. But in this case here, it will take a string as an argument and return a type of string. It will take a string as an argument and return Boolean. Take a string as an argument and return Boolean is the same as a predicate that takes a string. Inside C#, they define this predicate in the beginning in version 3 of C#, because they thought that would be smart. They're not using it that much. So probably do this instead of this inside. So what you get is a function. So you can define that as an argument to your method, that it should take some values. I think I actually tried to look into that yesterday. If they still have this upper limits, but it doesn't matter. It doesn't have any practical problems because you can only have 16 arguments here. Who cares if you make a function with 16 arguments? Your design sucks. So please go home and do something else. So if you run into this limit, it's just a small hint about your programming skills. So, but the problem in C# is that you have a type-safe language. Did we talk about that last time? What is a type-safe language? So what is a type-safe language? Yeah?
You have to give it data type, so if it's a string, it's a
Yeah, so you have to define the types everywhere. Whenever you use something, you have to define the type, and the type cannot change.
Yeah.
You cannot have a string here, and then later on you assign a double to that, and then it will switch into a double.
Like you can parse it.
Yeah, but then you have to define a new.
Yeah.
Whenever you define one variable, it will stay a string all its life. You cannot define x as a string and then later on say, I want x to be a double, and then I just assign a double to it, and then we'll say, fine, now I'm a double. You will see that JavaScript is different. It's not type-safe, so you can actually do something like what I just said. But of course, it has some. That's advantages and disadvantages relating to types, type-safe systems. So we'll talk a lot more about that. So, but since you need to have the type, you cannot just have a random list. You need to have types of them, and each of them. That's why you have this argument, although this constraint. Yeah. Yeah, so this is, let's try to make a small example, just to see, because it's very, what is it why is it useful? Of course, when we come to link, you'll see that it's used all the time, but let's make a small example and we try to use it, to see what is the benefit, how to use it. It's not necessary that you will be in this end of the programming problem where you need to define a function that can take another function as an argument. But in case you need to do that, we can try to make a small example. And actually, you need to do that for the next exercise. So I just start Visual Studio. You can do the same. Or Visual Studio Code if you're running Linux or not running inside the virtual machine.